This is problem 24 from chapter 3. We have the question. I changed this question a little bit just so it'll look a little bit different and you have to figure out the work in your homework. But it's going to be the same setup. A percent of licensed U.S. drivers that are female is 34.5. So this is a percentage. And then of the female drivers, there's 5.03 are 19 and under, 81.36% are 20 and 64, and 13.61 are aged 65 or over. And then here's similar information about the male drivers, but they don't give a percentage of all the male drivers. We'll figure that out in a minute. It says to complete the following. They want us to construct a table or a tree diagram. I think the table would be appropriate here, and then it's asking us to find some probabilities. So let's go ahead and do that. First of all, this piece of information, the 34.5 will go with the total female. So out of 100, we have the sum of the male and female percentages. So if we have 34.5 for females, then we must have 100 minus 34.5 for the males. So if you take 100 minus 34.5, we should get 65.5. Okay, so that's the easy calculations. Now we have to fill in the rest of this table. So let's figure out this box over here, the female and 19 and under box. So it says of the females, that's 5.03% are 19 and under. So it's not saying that 5.03% are 19 and under and female. They're saying 5.03% of the females are 19 and under. So for us to figure out what this box is, what we need to do is we need to do a calculation where we compute 5.03% of the females, which is a 34.5%. So if you remember the word of in a lot of cases, it becomes a multiplication. So what we're going to do is we're going to need to multiply these two percentages. And for me, I'd like to just multiply them as if they were decimals. So that's 0.0503, and then we want to multiply times, that's 0.345, and then I'm going to get a 0.0173. Now they want the answer as a percentage, so we need to make sure that we make this into a percentage. So that would become 1.73 or 74. So let's write that down. 1.74%. Alright, so we're going to fill in the rest of this similarly. The next box is an 81% or 81.36% of 34.5. Again, doing the same work. 0.8136 times 0.345, you get 28.06. Let's call that 28.07. So those are the females. Now for the males, out of the 65.5%, it says 5.04 are age 19 and under. So the same calculations, slightly different numbers. So we'll start off with a 0.0504, and then we'll multiply that with the 65%. So that's 0.655, and we get a 3.3%. And the next one is 81.43. 81.43 times 0.655. You get 53.33, 53.34. And then the last one. The next step is to fill in the totals, and the row total, the column totals are just the totals of each of the columns. So that should be easy enough to do. This looks like it's going to be 5.04. This added together would be, and then this last one would be 6, 5, carry 1, 13.56%. So we want to do a quick check to make sure that the totals for all these columns would add up to 100%. It's always good to just make sure that that's going to be working out. 5.04 plus 81.41 plus 13.56. And if we don't get exactly 100%, that's okay, because there's some rounding off that we had to do within this box. So if we got like within 1/10 of 100%, then that's okay. If you're off by like if you get 105 or 107 or something like that, then you might have gone a little bit too much where this is off. If you got like 200, then you're really way off. So keep those things in mind. Okay, so this is our table. Let's take a look at the next one. For part B, what's the probability that the driver is female? Well, we actually don't need to look at the table. It says 34.5% are female, so we already have that answer. So that's 34.5%. Now, this is a percent answer. If you want your answer to be a real number, then you need to change this into a decimal. So remember how to change into a decimal. Just move the decimal point 2 places to the left and drop the percent symbol. So this is 0.3450 if we're going to be officially rounding off to 4 decimal places, but that's not important. Part C is asking for the probability that your driver is 65 or over, given that your driver is female. So this probability that we're looking for here is, out of all the female drivers, what's the probability that we select somebody who's 65 or older? Well, the actual statement that was given here says exactly that. Out of all the female drivers, 13.61% are 65 and over. So we can just copy that answer down here, 13.61, or as a decimal, 0.1361. Okay, so both of these answers were obtained from the original problem. Okay, part D, probability that driver is 65 and over and female. So when we're looking for the probability that a driver is 65 and over and female, we're not looking at this number that they gave us, the 5.03, because this number 5.03 is actually saying, I'm sorry, we're not looking at this number 13.61. This number 13.61, as we saw in the previous problem, is the probability that we select a 65 and over person who's also female, or given that we're looking at the female population. Here, out of all the population, all the men and women that we're talking about, what's probably that they're both 65 and over and female. And so for that, whenever you see an "and" here, we should be looking at the probability that somebody's female and 65 and over. So this should be the value that we're looking at. That's 4.7%. So this is this is a percentage up here, 4.7%, and let's call that 0.047 for our decimal. So what is the difference between C and D? So in words, let's try to describe it in words. We'll say C, this is our answer. Actually, let's change pens here. So this is our answer for E. A probability 65 plus, given that they're female, is in words probability that we select someone who is 65 years or older from the female population only. So we're just restricting our domain, or restricting our population to just the female population, and then out of all those, the probability that we select somebody who's 65 or older. On the other hand, when we say probability 65 plus and female, this is the probability that we select somebody who is 65 years or older and who is also female. So we're not restricting ourselves to the female population only. We're looking at the whole population, and we're looking at somebody who's 65 and over and female. So that's why this particular probability is easy to obtain from this table, because they're just sitting right here. The other thing to note is that there is a relationship between these two, and there's a formula that we have where the probability that somebody's 65 or over and female is equal to the probability that we select, let's see, probably that we select somebody who's 65 and over, given that they're female, times the probability that we select somebody who's a female. So if we take a look at this, these these three answers over here, if we multiply this probability times the probability that they're female, we should get this probability, the and probability. So let's go ahead and check that. So 0.345 times 0.1361, and we get 0.469 or 0.047, 0.0469 or 0.047. Okay, so that checks out with our formula. So this is an important formula to try and remember, or at least write down. Alright, let's go and do the next problem. Driver is 65 or over. If we're just looking at the probability that the driver is 65 or over, this is any driver. It doesn't have to be female, so probability that the driver is 65 or over would be this 13.56. So for part F, this is the probability that the driver is 65 and over is 13.56%, or again as a decimal, this is 13. Let's call it 0.1356. And then here are being 65 and over and being female mutually exclusive. Well, mutually exclusive means that there's no drivers that are both 65 and over and female. Well, clearly we have this probability over here where somebody's both 65 and over and female. In fact, G 65 and over and female are not mutually exclusive because not mutually exclusive because the probability of 65 and over and female is something that we already computed, and it's 0.047. The fact that it's not 0 means there's something there's somebody that's both 65 and over and female at the same time, so it's not mutually exclusive. Okay, that is the problem, and hopefully it'll get you going with your homework. Good luck.